Okay, ladies and gentlemen, we're continuing with section 3.4. I'm going to call this part 3. There are two previous movies for this section. This is an OR statement, which makes it a compound inequality. The first step in an OR statement is to get the variable alone. So I add 5 to both sides of the inequality, giving me x is greater than or equal to 2. OR is in the middle. I get x alone here by adding 5, therefore x is less than or equal to 8. I put the first solution set on helper graph 1, so I bracket 2 because of the equals, and I shade to the right. All those numbers are on helper graph 2. Likewise on helper graph 1 rather. On helper graph 2, I have all numbers less than or equal to 8, so I have a bracket on the 8 and I shade forever to the left. Now the word in the middle is OR. What OR tells me to do is to union these two sets together. Not stop with just the numbers between 2 and 8. That's what AND would do. But these numbers come along also, as well as these numbers. Okay? In other words, what I end up picking up is the entire real number line. To get into an OR answer, you only have to appear in one of the helper graphs. These numbers appear in the helper graph, so they come. These numbers appear in the helper graphs twice, so they definitely come. And these numbers appear in the helper graph once, so they come. All it takes is one time. All real numbers, which we write in interval notation as negative infinity to positive infinity. And in set builder, it's a little weird. It's the set of all x's such that x is an element of the reals. Okay. Let's look at the next statement, which is an AND. When you have a compound inequality, your first step is to get the variable alone. So here, my first step would be to subtract 2. Negative 6x is less than negative 12. When I divide by a negative 6, the sign changes, and I end up with x is greater or larger than 2. On this part, I subtract 2. That gives me 3x is less than negative 18. When I divide by 3, there's no sign changing. X is less than negative 6. Helper graph 1 is all numbers greater than 2. There's a paren because it doesn't include 2. Helper graph 2 would be all real numbers less than negative 6, not including it, so there's a paren. AND means intersect. Find out what these two sets have in common. Well, if you look at these two sets of numbers, and if I asked you where would they overlap if you put them together, the answer is never. Therefore, this is an empty graph, which means that our answer is the empty set. Okay. Here's another OR, a compound inequality. My first step is to get my variable alone. Add 7 to both sides, which gives me 7x is greater than 8. When I divide by 7, no sign changing because I divided by a positive. X is greater than 8/7. Here, when I multiply by 5, always want to clear fractions, whether it's an equation or an inequality. I get the opposite of x is less than or equal to 15. This opposite sign is really implying there's a negative 1 in front of the x, so we need to divide by negative 1 both sides, which of course causes the sign to change. X is greater than or equal to negative 15. On the first helper graph, we have all numbers greater than 8/7, paren. On the second helper graph, we have all real numbers greater than or equal to, that's why there's a bracket, negative 15. When I put these together with an OR, I pick up everything from negative 15 toward infinity. And the reason is, on helper graph 2, the numbers between negative 15 and where I'm pointing, even though they don't appear in the top helper graph, they do appear in the bottom one. And for an OR, it only takes one appearance, so they come to my answer. And the rest of the graph you have points in common, but that doesn't matter. They didn't need to have to be in both graphs to come along. But they are, so they're going to come along just like the others would. Remember, OR is very easy. OR is union. You bring anything you see from either picture. So we end up with all numbers greater than or equal to -15. I bracket -15 with an infinity, because that's infinity. And in set builder notation, we have the set of all x's such that x is greater than or equal to -15. And we will come back to this sandwich in a minute on the next video.